Let's start with Newton's first law of motion, often called the law of inertia. Suppose we have an object and you place it on a table. How many forces are present on this object? We can count two. One of the force is due to gravity, which is also called the weight. Weight is equal to mass times the acceleration due to gravity. The other force is pushing it back up, also known as the normal reaction. These two forces have to be equal for this object to stay at rest. So we can write N equals mg. If two forces are equal, we say they form a balanced pair. So these are known as balanced forces. Therefore, we can say an object at rest will stay at rest if balanced forces act on it. Let's apply another force, pushing it to the right. Now these forces are not balanced. There is a total force pushing it to the right. This is known as unbalanced force. And we know that due to this force, this object is going to move to the right. Therefore, we can say that an object at rest stays at rest unless acted upon by an unbalanced force. So we can write that. This forms the first part of Newton's first law of motion. An object at rest is going to stay at rest unless you apply an unbalanced force on it. Let's move to the second part of Newton's first law. Suppose we have an object and we place it on a very smooth surface. Let's suppose it's frictionless. And we push this object to the right and give it some speed. After that, we don't apply any force on it. So we give this object some speed to begin with. Once again, let's see how many forces are present on this object. One of the forces is again the weight, which is balanced by the normal reaction. So this is a case of balanced forces. Since this object is very smooth, there is no reason for this object to slow down. This object will carry on with the same speed forever. Therefore, we see that an object will move with the same speed and in the same direction if balanced forces are applied on it. So we can write that as this is our second part of Newton's first law. We can collect both of those two parts into one law and write that as terms. Things don't just start moving or stop moving on their own. Imagine you're playing football. The ball won't move unless you kick it. And once it's rolling, it will keep going on until the grass or a player's foot stops it. This is inertia, the tendency of objects to resist changes in their motion. Now let's move on to the second law and understand Newton's second law by an example. Suppose we have an object and we apply a force on it. We apply a force F on it. If we double the force, the object is going to accelerate at twice the rate. It's going to move faster and faster. The more we increase the force, the higher the acceleration. The quicker the object is going to gain speed. Mathematically, we can say that acceleration is proportional to force. This equation means that if I increase the force, the acceleration also increases. But what happens if I increase the mass of an object? Let's suppose I place another block on top of the first one, which doubles the mass. Now what's going to happen is that this acceleration is going to slow down. So we can say that acceleration is inversely proportional to the mass. This inverse relationship means as I increase the mass, the acceleration decreases. As the mass goes up, the acceleration goes down. These two equations can be summarized into one neat equation, and we can write A, the acceleration, it's equal to F over m. This equation here has the information of both those equations. If I increase if I increase F, A is going to increase. If I increase m, A is going to decrease. I can rearrange this equation and write it as F equals ma, which is the Newton's second law. Newton's third law says that if an object pushes on another object, let's call this object A, and this object, in this case, this object is just two people. So if A pushes on B, then according to Newton's third law, B also pushes on A. That means if one body applies a force on another body, then the other body is going to apply an equal but opposite force on the first one. Another example would be when a person jumps out of a boat. Suppose this is a boat and a person jumps out of the boat. He pushes the boat backwards and the boat pushes him forwards. This also means that forces always come in pairs. Forces always come in pairs. Another example would be that of a rocket. So what happens is that this rocket, it pushes this gas out, it applies a force downwards on the gas, and the gas pushes back up on the rocket. People also like to summarize Newton's third law as, for every action there is an equal and opposite reaction. We must always keep in mind that action and reaction are forces. So in this case, if you call this as action, this force is going to be reaction. You may also call this one as action, then this one would be reaction. It's up to us. Let's quickly recap what we learned today. Newton's first law explains why object resists change in motion. The second law connects force, mass, and acceleration. And the third law reminds us that forces always come in pairs. These three laws form the foundation of much what we study in physics. Let's try and solve some questions on those three laws. The question says that we have a person who is standing on a horizontal surface. One of the force pulling him down is the force of gravity. In Newton's third law, this man pulled back upwards on the earth by same amount of force. But if this weight is pulling this man down, that means this man is going to press on the ground below. Let's call that force F. So this man pushes the ground by a force F. But then, by Newton's third law, this ground is going to push back on the man with the same amount of force F. If we isolate the man, we'll find that there are two forces on him. One of the forces is due to gravity. Gravity pulls him down and the floor pushes him back up, Since this man is at rest, these two have to be equal. So that means F equals W. The question asks us to find a relationship between W and F, between these two forces. Clearly they are not action-reaction pair, but still they are equal in magnitude, as we can see from this equation. That means it has to be option B. In this question, we have an elevator, and that elevator is going up with an acceleration of 5 meter per second square. A person is inside this elevator and he is also moving up with the same acceleration. The weight of the person is given to us. It's 800 newtons. But we know that weight equals mass times the acceleration due to gravity. Therefore, the mass of this person is going to be equal to the weight divided by acceleration due to gravity, which is equal to 800 divided by 10, which is 80 kilograms. So the mass of this person is 80 kilograms. To find what the scale reads, we have to find the normal reaction applied by the elevator floor. So we can use F equals ma and apply this on the person. So this man here is being acted by two forces. One is the weight, the other is the normal reaction. This F over here represents the total force, not the individual one, the total. The total in this case is N minus W equals ma. We can find out N as W plus ma. If we substitute the values, we get weight is given to us, which is 1200 Newton. So 1200 Newton is the force which the elevator pushes him up, and that's what the scale is going to read. Let's try another one. In this case, we have a block whose weight is 20 Newton. A force of 18 Newton is being applied on it, and the coefficient of friction is 0.4. We have to find the acceleration. First of all, let's find out how much is the frictional force applied on the block. The frictional force has an equation. The coefficient is 0.4 and the normal reaction is 20. So that gives us 8 newtons of frictional force. So that means 8 newtons are applied backward. If we use F equals ma on this block, the total force is 18 minus 8 equals mass of this object times the acceleration. That gives us 10 equals ma. But how do we find the mass? Once again, we use this information, the weight. We know the weight is equal to mg. And in this example, weight is 20 Newton and g is 10. That gives us mass of 2 kilograms. We can use this here, and that gives us 10 equals 2a. Therefore, acceleration is equal to 5 meters per second square. Let's try another one. If all the forces on an object are balanced, that means we have a case of balanced forces. And if we have balanced forces on an object, if the object is at rest, it will stay at rest. But if the object is moving, is going to carry on to move with the same velocity. That means it's not necessary that the object has to be at rest, neither will the speed change, nor its direction. That means D has to be the correct option. I hope you found this video helpful. I'll see you in the next video. Take care. Bye bye.